Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's Question Bank and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.
Starting with question number 1 here, we're being asked for 10% of 470. Now, to move a percent to decimal form, you need to take that decimal and move it 2 spaces left. So 10% of 470 is the same as saying 0.10 times 470. And what is 1/10 of 470? On the calculator, that would be 47, which is answer choice B. Going over to question number 2 now. Here we're simply being asked, how many students chose activity 3? Now the number of students, that's just the y-axis. So activity 3 seems to be coming in above 35, but below 40 and a lot closer to the 40. So I might even say something like 38, 39. And looking at the answer choices, 39 is the one being offered to us. So the answer here is B. Going over to question number 3 here. Here we're just solving an algebraic equation. So of course, we want to get x by itself, but we can't do that until we have this whole part by itself. So we can subtract 5 from both sides to get it by itself, and that'll give you 4x equals 160. And now you can divide both sides by 4, and you'll get x is 40. And that's our answer for number 3. For question number 4, we can start with the idea of price times quantity statements. We know that these oranges are $3 each pound, and we can say X is the number of pounds. So 3X, that's the whole amount of money spent on oranges. And the question is telling us that that comes out to 27. So now we can just solve this algebraic equation by dividing both sides by 3, and we'll get x equals 9, and that's our answer for number 4. Question number 5 is talking about f of x expressions, and let's just review that real quick. If you had, for instance, something like f of x equals 2x minus 7, the two main questions you'll get would be, well, give me f of 3. So putting something in that parentheses means you plug that in as x. And the other main way would be to say f of x is 3. That means y is 3. And so instead of plugging in for the x value, you take the entire thing and set it equal to that number. So those are the two main ways you'll encounter f of x expressions. Here, we're being told that the entire f of x equals 8. So we'll take that 4x, we'll set it equal to 8, and now you can just divide by 4 on both sides, and you'll get x equals 2, and that's your answer for number 5. Now going over to question number 6, this is another question about f of x expressions, where if you have a fundamental f of x, g of x, h of x type of expression, in there you can either be asked to plug into the x. So if something looks like this, it means you have to plug the x value in. So in this example, we would replace all of our x's with 3s. On the other hand, you can get something that looks like this, and that's saying that you're using the y value. So in this example, you'd set the y value equal to 3, which means to set the whole thing equal to 3, and then solve. So coming back to this question, the entire g of x is set equal to 25. So that's y, which, like I said, is the whole thing. So 25 equals all of this. Take away 9 from both sides, and you'll get x squared equals 16. And now the opposite of having it squared is to take the square root, so square root of both sides, and x comes out to actually plus and minus 4. You never know when you'll need that minus, even though here, obviously we didn't, and the answer is A. Now going to question 7, here we're being asked for a y-intercept, and you need to know that the x-intercept is the moment when y equals 0. The y-intercept is where x equals 0. So here we're being asked for the y-intercept. So that means we look for the place where x is 0. And x would be 0 everywhere on this green line. To be on that line, the y-axis, you have to have an x value of 0. And as you can see, when x is 0, y is clearly positive 8. So the answer here is D.
Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's Question Bank and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.
Now going over to question number 8, here we're getting a classic linear situation. Because if the cost of renting a tent has a one-time fee of 10, well, that one-time fee, that's your y-intercept. That's your b in a linear equation. So the fee starts at 10, and then after that, there's a cost of $11 per day. Well, that would be your slope, 11 times that y goes up every time x goes over by 1. So now thinking of this as an mx plus b, the y-intercept is 10, the slope is 11. And you can further confirm something like this by playing out the slope, by saying to yourself, slope is change in y over change in x. And here the y value is the cost based on, by the way, the number of days. So change in y, change in x is the amount of money, the cost, for every change in your days, the amount of money per day, which, like we said, was 11. In any case, converting this over to C and D, instead of being y equals 11x plus 10, the cost, C, is 11 times the number of days plus 10. So whether it's x and y or C and D, doesn't make much of a difference, but the answer here is C. Now going to question number 9, here we have a situation where we can benefit from getting some common denominators. Now, you can't really add fractions unless you have common denominators. One little thing I just did, if you didn't notice, is I took this negative sign and I made it plus minus. Now, those things are equivalent because if I'm subtracting, I am actually adding the negative of something. But part of the difficulty here is that this negative sign is kind of right there in the middle, and it causes confusion. Is it in the numerator? Is it in the denominator? And it's kind of hard to tell, especially for someone who hasn't seen this kind of math since middle school. So clearly putting it on the top gets rid of a lot of confusion. Remember, for fractions, one negative sign means something is negative. Two negative signs, for instance, let's say you had a negative over a negative, that would actually give you a positive. So one mistake might be to apply that negative to the top and the bottom, and that would also mess things up. But let's go ahead and start getting our common denominators now. We can multiply the one on the left by x plus 1 over x plus 1, and the one on the right by 4x minus 5 over 4x minus 5. Now, each of these fractions that we multiplied by, they're each equal to the number 1. Because when you have the same number on the top and the bottom, all you have is the number 1. And when you multiply something by 1, nothing changes. But that'll help us out because when we distribute 4 to x and 4 to 1, 4x plus 4. And when we distribute here, negative 1 to 4x, negative 1 to negative 5. So minus 4x plus 5. Once we distribute, we can just bring the denominator over and we'll pretty much be done. In the numerator here, 4x and negative 4x cancel each other, and 4 plus 5 is 9 over the same denominator, x plus 1, 4x minus 5, and that'll be our answer, 9 over x plus 1, 4x minus 5, which is answer choice D here. Now on question number 10, there are a couple of possible ways to do this, but let's try by getting our y-intercept, which is -5, and our slope, which is up 2 and over 1. Your rise over run from left to right, let's say from point A to point B here, turned out to be 2 over 1. So putting that all together into an equation of this line, we have y equals mx plus b, and our m was 2, and our b was -5, so y equals 2x minus 5. This might help a little bit in terms of figuring out the points, because it's basically saying that if you want your y value, you take your x value, multiply it by 2, and then subtract 5. So let's go ahead and put those into practice here. Here, the x value is 1. Multiplying by 2, you get 2. And taking away 5, you get -3. So we know this is wrong. Now going to 1 over here. Multiplying by 2, you get 2. Subtracting 5, you get -3. That's good. Here, multiplying by 2, you get 4. Subtracting 5, you get -1. And of course, for 0, you multiply by 0 and you get 0. Take away 5 and you get -5. So this actually didn't work there. Now let's go to C. C has exactly what we wanted. When you plug in the 0, you get -5, because that's 2 times 0, which is 0, minus 5, -5. 2 times 1 is 2, minus 5 should be -3. So that's the problem on that one. So now D has the 0, -5 that we wanted all along. When you plug in 1, you get -3, which is what we wanted on C but didn't get, because once again, 2 times 1 minus 5, that's 2 minus 5, and that is -3. And then plugging in X is 2. We'd have 2 times 2 minus 5, that's 4 minus 5, and that is -1. So the answer that worked here was D. Now, of course, we could have gone on the graph and plugged and looked up the 3 points. Look up the fact that at 1, it passes through -3, and at 2, it passes through -1. But the reason I use the equation is it might be a little hard to see if the points are small or hard to count. So the mathematical way to me is a little more dependable. In any case, the answer here is D. Now going to question 11. Here, we're being quizzed on our knowledge of parallel lines. If we're given the 110 here, the first thing I would do is I would put 110 right there, because those are called vertical angles, and they're always known to have equal measures. The next thing to point out is if you have two angles in this arrangement where the two angles put together give you a straight line, then one angle and the other have to add up to 180. So we can see relationships like that throughout here, but let's focus on this one right here, where this 110 and this other angle have to add to 180. So that's going to give you 70 for this angle. And just like the 110, this angle has a vertical angle on the other side, 70. Now, when you have parallel lines and a transversal, you should look at it as a fingerprint. So there's a fingerprint right here, and we're going to have that same fingerprint throughout. So here we'll have 110, 110, 70, and 70 will have that identical fingerprint, and that shows us that X is 70. In question 12, we're being asked about a rectangle. So let's go ahead and just draw a little rectangle here. And the length is 4 and the width is 9. So let's put 4 there and 9 there. And many people getting a question like this wrong would maybe say 36 because they're confusing area with perimeter. But if we do want the perimeter, then that's just the distance going all the way around. So if you were an ant walking the perimeter of this rectangle, how far would you walk? And the answer to that is 9 plus 4 plus 9 plus 4, which adds up to 26. And our answer here is D. Now going to question 13. This is called a literal equation. So if you find this one to be particularly difficult and you want to search for practice on situations like this, you can look up literal equations. Here, we're just trying to get J by itself. And we won't really be able to do that until we get the 8 away from it, because the way I say it, J is in that blue bubble, and you've got to get the blue bubble by itself before you can do anything else. Now here, the blue bubble's already by itself, so that makes things a little easier. So therefore, J is being multiplied by 8, and what we have to do is divide by 8. So divide by 8 throughout, and we can do the whole thing by 8, or, by the way, we can divide each individual piece by 8. So kind of looking at the answers, you can kind of see which one is preferable to get the right answer in this situation. And it's the one where you got the whole thing divided by 8. So here the 8's cancel, and that brings down just J, and that equals K plus 15M all over 8, which is answer choice D. Now going to question 14. Here we're being asked about the point 8, 2 on an XY axis. So here's our x-axis, here's our y. 8, 2 would be somewhere around here. Now, which set of inequalities involving the x and y axes would match this? Well, this red dashed line here, that's the line y equals 0, because everywhere on that line, the y value would be 0. That's why you're hitting the x-axis. And so if we want to include the point 8, 2, we need to be above that line, because 8, 2 is above that line. So let's just kind of shade this in here. So this right here is the expression y is greater than 0, because we've literally shaded in all the points where y is greater than 0. Now, we also want to be on the right-hand side, on the greater side of this green line here, because 8, 2 is on the right-hand side of that line. So if we shade to the right of that green line, now that green line, that's the line x greater than 0, because everywhere in this yellow region here, the x value is greater than 0. So x greater than 0 right there. And you can see from the darker yellow shading that this is the area that got shaded twice. And it's the area where the y value was greater than 0, which is above the x-axis, and the x value was greater than 0, which is to the right of the y-axis. So the answer here is A.
Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's Question Bank, and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.
Now going to question 15, this question is a lot easier than it looks. We know that we have a y-intercept that's positive. The y-intercept is a positive number. If we need the actual number, it's around 10. And we also know that the slope is a negative number. And that's because slope is rise over run as you go from left to right. So for this particular line of best fit that we're seeing, so the line that kind of looks like that, you can see that as you're going from, let's say, point A to maybe point B around here, our rise over run, it's actually not rising, it's on its way down, which is why the slope is negative there. So we're thinking about y equals mx plus b, which is the classic linear setup. And we're thinking that the m needs to be negative, so these two fit, and these two we can get rid of. And the b needs to be positive, so these two would have fit, and these two we get rid of because they have negative y-intercepts. So the one that we haven't crossed out here is B. Now going to question 16, this question is quizzing us on our understanding of exponential functions, and you definitely want to be able to recite off of memory the 3 elements of this equation. If you have something in the format of a times b to the x, you need to know that the a is the starting amount, the b is the way it changes, and the x is the number of times that happens. So coming back over here, we know it's an exponential because they're telling us it is. But we know also that the starting amount is the 36,100. So we can put that in as our A. Now, what we're calling X, the question is calling T, which is the number of years, by the way. And so we've already gotten rid of 2 answer choices here, by the way. Now, we could plug in X is 13 when Y is this big number here, and that will get us the answer. But there's also a little common sense that can help us choose between A and D. And that's because when you're changing something by a percent, it follows this format. The numbers start at 100. Let's just say we're increasing or decreasing by 25. We would go up or down from there. Up by 25 gives you 125%. Down by 25 gives you 75%. And then moving the decimal 2 spaces over, you'd get 1.25 or 0.75. The important thing to notice is that the number 1 is flat in the middle of this, because if I multiply a number by 1, nothing happens. In other words, if I take 100% of something, nothing happens. But if I'm increasing, I'm multiplying my number by something greater than 1. And if I'm decreasing a number, I'm multiplying it by something less than 1, between 0 and 1 to be exact. So looking at our answer choices here, we know that B is what it changes by, but the 2 B's that we have are 1.05 or 0.05. And according to what we said a moment ago, multiplying something by 0.05, a number between 0 and 1, that's going to make our number smaller. But we know from reading this scenario that our number does get bigger. It goes from 36K roughly to 68K. So because it's getting bigger, can't be getting smaller, the only possible answer here is A. Question 17 touches on something that shows up on the SAT in a really subtle manner. And that's the idea that when you have things in parentheses, now I know these are not parentheses, but absolute value symbols do kind of work like parentheses a lot of the time. So you have something in parentheses and you can kind of group them accordingly. In other words, we have 2 of these things and 3 of these things. Therefore, we have 5 of these things. And that's not breaking any math rules. Now, let's isolate that absolute value by saying, okay, well, the absolute value is currently being multiplied by 5. So let's divide it by 5. And now we have absolute value 4 minus x equals 5. Now, the reason we were isolating it to begin with is because if you have an absolute value equation, you have to have the instinct of taking away the absolute value and leaving it alone on the one hand, or taking away the absolute value and multiplying by -1. So here, if we had absolute value of 2x minus 3 equals 10, you'd get 2x minus 3 is 10, 2x minus 3 is -10, the plus and the minus. Now, by the way, the reason for that is if I take an absolute value of a number, let's say 10, well, that's going to be 10. But if I have the absolute value of -10, well, that's also going to be 10. So therefore, if I tell you the absolute value of the letter A is 10, you have no way of knowing whether A was actually plus or minus 10. So you have to kind of play out both sides. And that's what you're doing when you separate an absolute value equation that way. So for us, we can easily say 4 minus x is 5. 4 minus x is -5. Then we can start solving. Take away 4 from both sides here, and you'll get -x is 1. Multiply by -1, and you'll get x is -1. So ironically, the positive side came out to be negative. And that's not the one we want because we're being asked for the positive solution. So here we can take away 4 from both sides. We'll have -x is -9, divide by -1, or multiply by -1, however you like to say it. And x comes out to +9, and that is our positive solution. So that's our answer to question 17. Now going to question number 18, here we have a factoring situation because this original expression is then being factored out, but we don't know what exact numbers have been taken out in order to give us the 15y minus 9 in the parentheses there. But let's say we did have a number right here and we were trying to multiply it out. We would multiply that number by 15y, then we'd multiply it by -9. So if we want to know what number we took out, just think about, well, what number has to be multiplied with 9 to get 54? And the answer there is 6. And how many y's needed to be taken out? Well, 4 of them do. So let's just write it in here. It'll be easier to see. So if we say that there are 4 y's being taken out, now 6y to the 4th times 15y, well, that is going to give you 90y to the 5th. And 6y to the 4th times -9, that's going to give you -54y to the 4th. So by kind of dividing, we figured out what you must be multiplying by to get this answer. So the question told us that this is r y to the 4th and was asking us for r. Well, we can see clearly that r is 6 here. Now going to question number 19. Here we're being told about a rectangular cutting board. So let's put a little rectangle on here. And we're told that the width is W, but the entire area is W times W plus 9. Now, of course, the area of a rectangle is the length times the width. And if we know that one of these things is W, the thing that's multiplied by that, if we know for a fact that that's the area, well, that must be the length. So W plus 9, that has to be the length for us to then be able to say, well, the area is the length times the width, W times W plus 9. So which of these expresses the length? That's the W plus 9, which is answer choice D here. Now going over to question 20. Here we have an inequality. Y is greater than 13x minus 18. One way to make sense of this is to just think about the line y equals 13x minus 18. Well, that's a y equals mx plus b. So our slope is 13, which, by the way, is 13 over 1. So from a rise over run standpoint, it means you'll be rising 13 and running 1. And the y-intercept, the b, well, that's -18. So let's create a little graph here. This is definitely not going to be to scale because the numbers will be really strange. But it's going to be hitting at -18 on the y-axis because that's our y-intercept. So this point right here, this is 0, -18. And from there, we can continue to go up 13 over 1. So for the first stop, up 13 and over 1, let's say that this is 1, -5. Up 13 over 1 again, that's going to take us to 2 and 8. So let's put that around here somewhere. 2, 8. Up 13 over 1 again, that'll take us to 3, 21. And let's continue it more and more. Up 13 over 1 again, that'll take us to 4, 34. So we're adding 1 to the x and 13 to the y. So continuing onward, 5, 47, 6, 60, 70, 73, and last but not least, 8, 86. So now we have a much stronger idea of where our line and our inequality will lie. So I'm going to draw a little line here to represent this idea. Now that line should be a dashed line because less than and greater than is a dash situation in math. Less than or equal to, greater than or equal to, that's solid. So let's see if I'm able to make dashes here. Okay, and that's much better. Now, remember, we're not dealing with y equals 13x minus 18. It's y is greater than 13x minus 18. So we need to shade above right now. So let's shade above this line. And this yellow zone, that is our solution set. Any points that are correct right now have to be in this yellow area. Now let's look at the answer choices. A is giving us 3,21. Now, if you're greater than a certain line, you can't necessarily be on that line. So 321 is out. It would have to be 322, 323, something that says that, yeah, we are above that line, not directly on it. Similarly, 316 has to be out because that's definitely below the line. It's got the same x-axis, but it's below because it's got a lower height. So then we've already gotten rid of A and C. 326, well, that's okay. That's around here. And choices B and D both have that point, 326. So now in answer choice B, let's look at the 5 and the 42. Well, when we have 5, our height is 47. So 542, that's going to be below. And that's bad. We needed it to be above. So 542 is also out, in addition to the 321s and the 316. But the 542 is out, and that also removes answer choice B for us. And so the only one where we haven't yet found any points that don't fit is going to be D. But let's confirm those points. We've got 326, which is like right here, 552, which would be above 547, and 891, which would be somewhere above 886. So the answer here is D. Now going to question number 21. Here we have the original f of x function, and looking right at that, we already know what the x-intercepts are. And the reason is because your x-intercept is the place where y is 0. By the way, the y-intercept is also where x is 0. So if we imagine that y is 0 for the original f of x function, then we would have something that looks like this. And next, we would need to use the zero product rule, which says that if multiple things multiply out to give you 0, that could only happen if one of them actually was 0. So the zero product rule is your permission for setting each piece equal to 0 and solving. So we have 3 answers, and these are our x-intercepts. This thing hits the x-axis at -6, 0, 5, 0, -5, 0, and -1, 0. Now, if we consider this part right here, we know that we're moving our function one space, but the question is in what direction? And just as an example, let's say we have a regular y equals x squared. If you add to the outside of that, that's a vertical shift, and vertical shifts are normal. So if I do +5 on the outside, that's going up 5. It's pushing our parabola that way by 5. On the other hand, if you add 5 on the inside, if you add to the inside, that's a horizontal shift, and those are backwards. So normally, in terms of left-right, positive is to the right and negative is to the left. This is backwards. Positive would be to the left. So this is left 5 from the original function. And in f of x notation, the original one, well, that's like our f of x. This would look like this, f of x plus 5. And this other one, it would look like this, f of x plus 5. So now coming back over, g of x is f of x minus 1. And according to what I just showed you, that would be a move to the right by 1. Because adding on the inside is a horizontal shift, and horizontal shifts are backwards. Positive is actually to the left, and negative is actually to the right. So negative was to the right here. So if we take our 3 x-intercepts that we had on the original function, we have to realize that all 3 of those have been moved 1 to the right. So just imagining where those points are and what would have to happen to move them to the right, you'd get -5, 0, -4, 0, and 0, 0. So this question is asking us for this new g of x function that involved moving f of x 1 to the right. What are the x-intercepts? And we have them. They're -5, 0, -4, 0, 0, 0. And that means that according to the a, b, and c that they're giving us, a is -5, b is -4, and c is 0. A plus b plus c would be -5 plus -4 plus 0, and that comes out to -9, which is b. Now going to question 22, we have a square inscribed in a circle. So let's go ahead and imagine the circle, and then let's go ahead and imagine a square inside that circle. Now, we're being told about the radius. So the best way to relate the radius of this circle to the square is to go diagonally. So this diagonal radius here has a length of 20 root 2 over 2. Now, the way to relate that radius to the square is through right triangles. Because if that radius is 20 root 2 over 2, then this diameter is 20 root 2 over 2 plus 20 root 2 over 2, which mathematically is 40 root 2 over 2, and that simplifies to simply 20 root 2. So we now know that the hypotenuse of this right triangle is 20 root 2 without the denominator. Now that hypotenuse, the diameter of the circle, that is part of an isosceles triangle. Because what is a square after all? It's a rectangular shape where all 4 sides are the same length. And so by that token, this green triangle right here is an isosceles triangle. And why do we care? Because any isosceles right triangle is automatically a 45-45-90 triangle. And you should know that ratio by heart, even though it's given to you on the formula sheet. The ratio for the 45-45-90 triangle is x, x, x root 2. Now, by the way, you can also work this using Pythagorean theorem, but special triangles, the 45-45-90 triangle, is definitely quicker in this situation. So the same diameter of the circle, which is also the hypotenuse of the right triangle, we already knew from the beginning that it had a length of 20 root 2, but in terms of that right triangle, in terms of that 45-45-90 triangle, it's also x root 2. So we're finding out that the x of the 45-45-90 triangle is 20. And that tells us that these two sides are also 20. And so now we have the answer to the question. What is the side length of the square? We just saw that it was 20. So the answer here is A.
Join today to take your SAT prep to the next level. Members get access to over 1,000 solution videos answering the questions in College Board's Question Bank and concept-based practice questions with videos to solidify your SAT skills. Thanks for watching. Grateful.